this is section 3.1. We're going to be going over some probability stuff and also some counting principle stuff. So for the first one here, we have to find how many license plates can you make if a license plate consists of 4 letters and 2 digits, assuming the letters and digits can be repeated. So first of all, if you're thinking of your letters here, there's 26 letters in the alphabet. And if you're looking at your digits here, you've got 0, 1, 2, 3, all the way up to 9 for each individual digit. So for the letters itself, there's 26 of each letter and 10 options for each digit. So since we have 4 letters, we're going to have 26 to the 4th power. Or that's the same thing as doing 26 times 26 times 26 times 26, doing that 4 times multiplied by itself. So remember that is in the exponent position, not being multiplied by the 4. It's in the exponent, and then times that times 10 to the 2nd power, since there's 10 options for each digit, and there were 2 digits. So this has to do with that multiplication rule, or sometimes called the counting principle. So here, if we multiply that out here, what you should get for an answer is 45,697,600. And be a good idea for these, make sure you do remember how to enter those into your calculators correctly. Make sure you get the same answer there. For the next one here, it says that you select a card at random from a standard deck of cards. And you want to find the probability of selecting a black ace. And keep in mind, if you're not very familiar with the deck of cards, in your book on page 132, it does give you a list of what all the cards are, what the colors are, what the suits are, and all of that information. So if you don't already know that, that'd be a good place to reference that, so you know it in case it's on a quiz or test. So if we look at the black aces, there's 2 black aces. There's one in spades and in clubs. So we have 2 out of, and then in the entire deck of cards, there's 52 cards. We're not counting any jokers. So then if we simplify that there, we get 1 out of 26 by dividing 2 out of the numerator and denominator there. So some of these are going to be a little easier than others. Depending on how familiar you are with these topics, of course, it's also going to depend on how easy or difficult these are going to be for you. For the next one, we have to find the probability of a student getting an A in a class based on the following frequency distribution. So here in this case, it says that there were 5 people that got an A, 12 that got a B, and so on. So to figure out our probability, we already know how many got an A. So we're going to have 5 out of, and then we always need to divide by the total possibilities for whatever's going on. In this case, our total is going to be what we get if we add up our frequencies, or the sum of our frequencies. Remember, that's what this symbol here means, is that you're talking about your sum, or what you get whenever you add up that column for your frequencies. So if we do that here in this case, we get 41, which means we'd have 41 in the denominator here. In this case, this fraction does not simplify. So if you prefer, you can just keep it as a fraction there. If you keep it as a fraction, though, make sure you do check to make sure it's simplified all the way. Or if you prefer, you can divide that out and approximate it as a decimal. Make sure if you approximate it as a decimal that you got at least 3 decimal places for these. So if we do that, we'd get 0.122. And then example 4 is just finding the complement of example 3. And the complement is the opposite of that event. So in other words, the probability of a student not getting an A. So the probability of them not getting an A is going to be 1 minus the probability that they did get an A. Or if you prefer, you could go through and you could add up all these frequencies here, the 12, 15, 7, and 2, and divide it by 41. Either way, you'll get the same answer. So if you do it this way, if you're doing it by hand, you'd have to get a common denominator first, and then you can subtract them. So if we do that in this case, we get 36 out of 41. Or once again, if you prefer, you could write it as a decimal. We could have 0.878 approximately. That's where also, if you have this decimal 0.122 from example 3, you could also do 1 minus that 0.122 to get an approximation there as well, instead of having to work with the fractions there, if you don't like working with fractions. That is another way to approach that. Make sure, like normal, if you have questions on any of this, make sure to ask in class or during my office hours.